Hey, welcome. Today, we're jumping into a really cool way of teaching sixth grade math. It's all about taking these huge abstract numbers that can make your head spin and turning them into something you can actually feel, something practical, and honestly, kind of epic. Okay, let's get into it.
So think about it for a second. How do you make a number like, say, $900,000 actually feel real? It's easy to see the digits, but to understand the sheer scale of it, that's a whole different ballgame. We're going to break down a curriculum that tackles this exact problem with a pretty surprising solution. And that solution, believe it or not, starts with an ancient story. Instead of just throwing equations on a whiteboard, this whole lesson plan wraps every single calculation inside one big, powerful narrative. It's a classic tale being used to solve a very modern teaching challenge.
And there it is. This one idea sets the stage for everything that follows. Every math problem we're about to look at is tied directly to this massive real-world project. So the students, they're not just students anymore. They're basically project managers, and they've got a city to rebuild. You see, this is the big idea. The story gives the math a why. All of a sudden, adding, subtracting, multiplying, dividing, they aren't just abstract rules you have to memorize. No, they're the essential tools you need to get the job done, to organize materials, manage your supplies, and get your workers where they need to be. All right, so this is where the rubber meets the road. We're going to walk through the actual homework problems, and you'll see how each one is framed as a specific task for our city rebuilding crew.
First up, addition. But this isn't just add number A to number B. The task itself is a logistics problem. You've got two absolutely enormous stockpiles of bricks, and you need to know your total inventory before you can even think about starting to build.
And look at these numbers. We're talking tens of millions of bricks here. Framing it this way turns a simple calculation into a concrete action. You're taking inventory. So, what do you get when you put it all together? Whoa. 55,913,568 bricks. That's your grand total. Just saying that number out loud really makes you appreciate the scale of what's happening here. Okay, what's next in any big project? You start using your supplies. So subtraction becomes the next logical step. The task is all about resource management. As the walls go up, how many bricks do we actually have left in our stockpile? And here's the setup for that. You start with a huge pile of 50 million bricks. The construction crews have been busy, and they've used up over 5.5 million of them. The question is a practical one. What's left in the inventory? And there's your answer. Over 44 million bricks are still ready to go. You see how each calculation keeps the story moving forward? It shows progress and the kind of careful tracking you'd need for a project this massive. Now, the lesson also cleverly weaves in specific math techniques. One of them is the distributive property. I know, it sounds a little intimidating, but it's really just a smart way to handle big multiplication problems by breaking them down into smaller, bite-sized pieces. And this is how the lesson shows it. Instead of trying to multiply 123,456 by 10 all at once, you break the big number into its parts first. This is more than a math trick. It's a way of thinking. It's about deconstructing a huge challenge into smaller, solvable steps, exactly what you do on a real construction project. And finally, we get to division. And again, this isn't just a stereo equation on a page. It's a very real problem of logistics and, people. You've got a ton of bricks that need to be moved, and you have to figure out how to divide up the work fairly and efficiently among your team. So here's the specific challenge. We have to move 876,543 bricks. And from experience, we know that each worker can handle about 9,999 of them in a shift. So the math problem is also a management problem. How many workers do you need to get this done? The answer? It's 88. You need 88 workers for this specific task. The math gives you a clear, actionable number. It's exactly the kind of info a project manager would need to organize the day's work. But a good manager doesn't just run the numbers once and call it a day. They check their work. And this next part of the lesson is brilliant. It connects the mathematical habit of verifying your answer with the real-world idea of diligence. It's all about making sure your plan is solid. And this is how you do it. The plan was made using division. The check is done with multiplication, the opposite operation. You can see the numbers are super close, which confirms the plan is solid. It's a perfect parallel for how you double-check your logistics in the real world before sending people out to work. So, as we've seen, this whole method is about way more than just getting the right answer. This last section really gets into the deeper intention behind the lesson. It's about connecting the how of math with a greater sense of why.
The lesson actually ends with this Bible verse. Now, no matter what you personally believe, its purpose here in the lesson is pretty clear from a teaching standpoint. It frames this whole exercise of wrestling with these huge, almost unimaginable numbers and places it in a context of a limited potential and purpose. It suggests that mastering these skills is part of something much bigger.
So let's just recap what makes this approach so powerful. First, it grounds abstract math in a story you can actually picture. It turns sterile operations into practical, real-world tasks. It doesn't just teach you how to get an answer, but also how to be diligent and check your work. And finally, it connects the nuts and bolts of math with a real sense of purpose. And that really leaves us with a fascinating question to chew on. We just saw how one powerful story can light up the world of complex math. So, what other stories could we use? What kind of narratives could make subjects like physics or economics, or maybe even computer coding, feel more real, more meaningful, and just easier to get your head around? It's a pretty powerful thought about the connection between stories and true understanding.